And that now we know what are the physical quantities. Now let's have to extend our discussions by looking at the dimensions, or should be a dimension. So what is the dimension of a physical quantity? So this one is said to be the measure of a physical quantity. That is the dimension. And for instance, we have a physical quantities like the fundamental physical quantities. We have the time, we have the length. Mind you, the length is the same as a distance. And we have, let's say, the mass. And basically, these are the major fundamental physical quantities. So what are their respective dimensions? So now the dimensions are expressed actually inside the square brackets. And for instance, the dimension for time, it is given as the d in the square brackets. And for length, it is given as the L, given as that. And for the mass, it is given as the capital letter, actually M. So these are the dimensions for the actually fundamental physical quantities. And how about the dimensions for the derived physical quantities? In the much as the dimension actually much as the derived physical quantities, these are the quantities that are expressed in terms of the combination of either 2 or 3 of these actually fundamental physical quantities, then it is true that the actually derived physical quantities will consist with the combination of these 2 or 3 actually the dimensions for the fundamental physical quantities. So keep that in mind. For instance, we have a derived physical quantity like a time. Should be a speed, rather speed. Now let me use another ink here, the general one. Let's say we have a speed. So now a speed is given as the distance over time, of which the distance corresponds to length and the time corresponds to, just have to say time. So what are the dimensions for the speed? Now the dimensions for speed will be given as this. We'll have the square bracket given as the length divided by the square bracket given as the time. So that's the measure of the speed. And what if we have this case? Let's say we have, let's say, the force. So the force is given as the mass times acceleration, and of which acceleration is said to be the velocity or the speed over time. So what is the measure of the force? So now the quantity for actually a mass, so the measure or the dimension for the mass, it is given as the capital letter M. So have the capital letter M like that. In the times, what is the measure of the acceleration? We have the velocity or the speed divided by time, which corresponds to the length. That should be like this, of course. That corresponds to have it as, now of course this is the same as having this. Let me just have to represent this way. So have it as the length over time, and that divided by now this time. That will be given as the t. Should be that. And of course this is the same as having it as, now have it as the mass. So should be the capital letters, actually should be the capital letters times the L divided by d to the power -2. So which means this is the measure of the force. So keep that in mind. How about if we have this case? Let's say we have the power. So the power is given as, let's start with, should be energy first. So should be the energy or work. So work is said to be the force times distance, and of which, what is the measure of the force, as we have recently discussed it about. And what is that of the distance? You can be able to have the dimension for the actual work. And also at your own time, try to have the following dimensions. Actually try to have the dimensions of the following quantities. Let's say have the pressure, What is the dimension for pressure? You should also have to try that one as well. What is that of, let's say, moment of inertia? You also have to try moment of inertia. Try to Google or whichever the source to have the dimensions of these two, of the following quantities. And what is the angular velocity? Also try to have angular velocity. Also try to have this specific heat capacity. So specific heat capacity, try to Google it out. What are the dimensions that for those aptitude quantities? You also try to have elasticity. What is HC dimensions? Should be that elasticity. You also try to look around the density. So try to look for their dimensions. And how about the volume? Try to look over that one. And also gravitation constant. Also try to Google it out. Gravitation constant. So gravitation constant. Try to look for that one as well at your own time. And also try to have the following. Should be the coefficient of velocity as well. Coefficient of velocity. So try to Google it out. What is the dimension for that one? And I also have the angular momentum. So what are the dimensions for that the angular momentum? So try to go through that one as well at your own time. Now the following are the tasks for you. You should have to determine the relationship between the units of a quantity, and the dimensions. Do we have any relationship between the unit of a quantity and the dimensions? Is it possible that if we have the dimensions of a quantity, we can be able to draw the units from the dimensions? Or likewise, you should have to try to look for that relationship if it is there. And another task for you is that, is it possible to add or subtract the quantities with different dimensions? For instance, we have 2 seconds plus 5 meters. Is this possible? Or let's say 2 meters per second minus, let's say, 5 kg. Is this possible? If it is yes, how? If it is not, how? Why? You should have to try to look for the solutions or the responses to those cases. So I'll need the responses in the comment sections below. So try to have those cases out. Thank you.